Okay, it is 3 o'clock, and I got an opportunity to have my adrenaline elevated right before I came over here. I had the room number wrong, so I went to the wrong room, and Rob Farley and Buck Woody were in there rehearsing their song, which they're going to play at the keynote tomorrow morning, I heard. So, I mean, that was just so captivating. I stood there and listened. Am I supposed to be in this room? And then had to run over here. And the other thing was, when I was shutting down my computer in the speaker room, I get the message, do not shut down machine, wait for updates to complete. And I wait, and I wait, and I wait. And finally, I just slammed it shut and came over here and opened it up, and it's still installing updates. So I had to shut it down and boot it up again, and it didn't act really friendly when it booted up. So it gets the adrenaline going a little bit. So now we're nice and charged and ready to go. It's looking okay now, but we'll just have to keep hoping it stays this way. So welcome. Thank you very much for coming this afternoon, even though some of you might have noticed there's like 4 sessions this week on the same topic. Now, probably they won't all be exactly the same with the same demos and exactly the same details, but there are 4 sessions this week about the plan cache. So hopefully, even if you attend multiples, you'll be able to just get the information that you learn reiterated and reinforced. This is one of my favorite topics to talk about because, at least for people who aren't really aware of what's going on with caching, what gets cached, and when plans get reused, once you find out when a plan is reused and when it isn't, it's one of my top 3 features for making major performance improvements in your applications and your queries. And it's something that a lot of people aren't even aware is an issue. So I really love teaching about this, especially to people that really haven't seen much about it before. So I've got the abstract here, but I think I won't just read this. A little bit about myself, about my background here. I've been working with SQL Server for a long time now. In fact, in just a couple of weeks will be my 24th anniversary week working with SQL Server. I started with the Sybase Corporation. My first day of work there was October 27th, 1987. And it was just very fortunate for me that it was Sybase that Microsoft went into partnership with, so I had a head start in learning about Microsoft and their database product, and I've never looked back. I'm really, really grateful for the opportunities that I've had and the work that I've been able to do and the appreciation that I've gotten from people that I've been able to work with and write for over the years. So I want to remind you again about this incredible project that 53 of the SQL Server MVPs have been involved with. Those of you that came to our book signing yesterday, I'm really, really grateful that you were able to support us in this way and be as enthusiastic as we all were. I just found out this morning that Manning is shipping another few cases of books to the bookstore. However, they will not arrive in time for tomorrow morning's book signing. But if you didn't get a copy of the book, and here's my commercial here, all of the royalties are being donated. None of the MVPs are making any money from the book. It's all being donated for this volume to Operation Smile. And the books will be arriving probably by 11 or 12 tomorrow morning. You can find authors wandering around the conference by looking for... There are brown ribbons with gold lettering on the badges, and it says MVP Deep Dives Author. So if you haven't got a book yet and don't make it to the book signing tomorrow morning with one, look for authors by their ribbon. So what are we going to talk about this afternoon? I'm going to tell you about what plan cache is used for. I'm going to talk about the different mechanisms that SQL Server uses for caching. And then what we're going to look at is the metadata that's available to show you what's in cache, to allow you to tell what's happened with your plans, when they've been reused, and also a little bit of head start on figuring out when reusing the plans is a good thing and when it's not a good thing. And we can tell that sometimes by looking into how the plans were being reused by using the cache metadata. So we'll start with an overview of what goes into plan cache. We're not talking about data cache. We're not talking about your data pages, index pages going into the buffer pool. We're talking about cache that holds your query plans. How many of you use SQL Server prior to version 7? Wow, wonderful. So you are aware of massive changes that happened in this area. Prior to version 7, the only kind of plans that SQL Server could save were stored procedure plans. In addition, prior to SQL 7, memory was a lot more rigid in the way that you set up the space available for different components. There was you set a size for plan cache. Well, not really, you set a percentage, but basically there was a fixed size to be used for plan cache, and once your SQL Server was up and running, that size wouldn't grow and it wouldn't shrink, which led to some interesting memory management problems. That's not what we're talking about. Matya has a session on plan cache right after this one, not in this room, somewhere else, and he's actually going to be talking a little bit more about the actual memory involved in plan caching. We'll have a first introduction to the metadata that's available, but a little bit later in the day, or in this session, we will go into some more details about the metadata. So, sometimes I give this session in conjunction with information about query plans and query tuning, and so I relate the two together. We don't have time in just an hour and 15 minutes or even an hour and a half to really go into lots of details about query plans. So I'm going to have to assume that you've got some basic information about what a query plan is, the kind of information that shows up in your query plans, what indexes, what order of operations, what kind of join is being done. And when you look at a query plan, you should be aware that there are two different flavors of the plan that you can look at. You can look at what we call an estimated plan, or you can look at an actual plan. And the simple definition of estimated versus actual is that the estimated plan is the plan that's generated without running the query. The estimated plan is basically just SQL Server saying, if I were going to execute this, this is what I would do, but it doesn't actually go and do it. It's just estimating what it would do. An actual plan is the plan at the time it's running the query. And in most cases, these are similar. And in many cases, they're exactly the same. However, there are some places where estimated plans and actual plans can be different, but that's beyond the scope of what we're going to talk about this afternoon. One detail, though, I will mention about estimated plans is that they do not store any actual parameter values that were sent in. When you look up an estimated plan, the estimated plan just shows the value used to generate the plan, not the value that the plan was run with. And it's only the estimated plans that are available after the fact. At the end of the session, when we actually start poking around inside the plan cache, we'll be able to pull out the estimated plans, but not the actual plans. Another thing to be aware of when we start looking at the cached plans is that the plans are cached on a batch level. Each batch produces a plan. The batch may have multiple statements in it. It may be a single select statement. It may be 3 or 4 select statements. It could be the plan for a stored procedure, which has tens or dozens or thousands of statements in it. Each batch makes a plan, and when we look at the plan cache metadata, each row is the plan for a batch. So the statements are optimized individually. One statement at a time is sent to the optimizer to get the plan for this one, get the plan for that one, but then the plans for all the statements are combined together, and that makes the plan for the batch, and that creates a row in the plan cache metadata. So I'm going to show you some simple metadata first, just so we have something to look at as we first get started. Those of you that have seen me present before know that I really, really love showing what I'm talking about and not just talking about what I'm talking about. I really love to do demos. In fact, when I'm doing a class, I'm bouncing back and forth between slides and demos all the time. I don't have a specific, now we will have a demo slide. I do that when I have conference presentations, but in my classes, you can hardly tell the difference from the class presentation versus the demos. So in the first few demos, I will be using some simplified metadata, which is based on a metadata view called DMExec cached plans. Now, if you took a direct look at DMExec cached plans, which we will near the end of the session, you would not be really impressed. It's actually very, very cryptic. There's not a lot of immediate value that you can gain, especially if you've never looked at very much detail about the way caching works. In order to really get value out of DMExec cached plans, you need to combine it with some of the other metadata, and I will be showing you how I do that. Another way to look at cache is to use a compatibility view, which was available in SQL 2000 and earlier as a pseudo table called syscache objects. Syscache objects basically takes the information in DMExec cached plans and translates it or combines it with other metadata to give you something that's a little bit more meaningful, that has a little bit more value to it. Now, I could select from syscache objects to give you the meaning that I want, or to give you the values that I think are going to be important for us. However, because I'm a metadata junkie, what I decided to do instead was to take the new metadata, some of the dynamic management objects, and combine them together and create a new syscache objects. And so I do have a script to create my own syscache objects. I will show you that in just a minute in the first demo. What we will see when we start looking at plans is there's actually 6 different types of plans that can be cached. But only 2 of them are going to be interesting to us. We're going to be looking at compiled plans and compiled plan stubs. The other 4, parse trees, extended procedures, and the CLR objects, aren't ones that are really tunable, at least not the way we're going to be talking about it right now in this session. So I'm going to ignore those for today. Within the compiled plan category, there are 3 different types of objects. There's a column in the output that we'll see called cache obj type. That's the compiled plan versus parse tree or these others. But then there's another column called obj type, which has one of the 3 object types: ad hoc plan, prepared plan, or procedure plan. We will be looking at all 3 of those types. Another column that we'll be looking at in the metadata that I'm just about to show you is a column called use counts. There is a column that will tell you how many times a particular plan has been used. So you can tell if some plan is really, really popular and has been used over and over and over again, or you can tell if a plan has been used once and never been reused. And if you have a cache where you notice tens of thousands of plans, all with a use counts value of 1, we have a name for that. We actually call that cache bloat. We're filling up our cache using all kinds of memory to hold on to plans that are never even being reused. For memory management purposes, this is not a really pretty picture. 2008 actually gave us a way to reduce the impact of cache bloat, and I will be showing you that in one of the demos very shortly. The other tool that I'm going to be using besides the metadata is a dbcc command, which allows us to clear out all the plans. We have an option called dbcc free proc cache, which clears out all the plans across your entire SQL Server instance, or we have a subset of that just to clear out plans for one specific database. There's actually also an option to clear the plan just for one particular query, but we're not going to be looking at that one. Keep in mind, this is not recommended in a production environment. In most cases, you want caching. Caching is normally a good thing. I'm going to show you some cases where it's not. But just because there's exceptions to the rule doesn't mean that you should do away with it completely. Of course, you're all well aware of that. I will show you some places where reusing cache plans is not a good thing, but in general, caching itself is still good, and clearing out cache just because you know how to do it is not recommended. So the first demo will just look at some basic metadata, and it will show you the view that I've created to simulate the old syscache objects, which went away, or not went away, but it was revamped as of SQL 2005 when all the metadata was redefined. So I have a script, and you will have access to all my scripts. All right, I opened up Management Studio before I changed my screen resolution here. And the code here is not so important right now. What I want to show you is that I'm creating a view called SP_cache objects. Now, some of you might be surprised. If you've ever taken a class from me, you're probably not. But if you haven't taken a class from me and you haven't looked a lot at system objects, noticing a view starting with SP_ might look like a surprise. And that would only be true if you thought that SP stood for either stored procedure or system procedure. How many thought it stood for one of those? Now, you don't have to admit it. Just know it in your mind. It doesn't stand for either stored procedure or system procedure. SP, as the initial part of an object name, actually means special. SP is special. You can create almost any object to start with the 3 characters SP_, and if you put it in the master database, it has special properties. If you think about the SP_ objects you're used to, SP help, SP who, SP lock, the system stored procedures that are special because they are accessible from anywhere. They're created in one place, but you can be in any other database and access them easily. So if I create an SP_ object in the master database, it becomes a special object. And what my SP_cache objects will do is it will select from dmexec cached plans, which I told you was the relatively cryptic view, and it joins it and combines it with some other elements which we're not ready to look at just yet. But the where clause is probably important to be aware of. I'm filtering this only looking at objects that are compiled. I don't care about my parse trees or my CLR objects for my purposes today. So I don't want to be bothered with them. I want to eliminate anything that isn't either a compiled plan or the other compiled type, which was compiled plan stub. So I will create this, and now I can use this from any database. I can go to any day. I'll be using my AdventureWorks database, and I know I forgot to open up my my Zoomer. Zoom it there. No. I'm not going to be doing too much other than just code, which I think, where's Zoom it? There we go. I'm not going to be doing too much that I'm going to need zooming for because it's all going to be code, and hopefully my font is big enough, but if it isn't, I can enlarge it. Where are we? Excuse me. Now I am in my AdventureWorks database here. Even though I created that object in master, I can say select from SP cache objects, but then I need to be able to spell, of course. And I get a whole bunch of things, but they're all compiled plans. I have 88 rows in my cache, and I just booted up my computer right before I started talking here. So lots of things get cached, even if you're not aware of it. If I do a dbcc free proc cache, and then select again, it should be empty. But it's not. Let's try it again. Clear it out. Look at cache. Why isn't it empty? What am I seeing here? Any guesses? I'm looking at myself. I am looking at running sp_cache objects, which also has some underlying code, which becomes a cached plan. So I always think of this as like the Heisenberg uncertainty principle of SQL Server, that you can't examine a system without affecting the system. I cannot look at cache without affecting what's in cache. My act of looking creates a plan in here. And in fact, what we can see is this use counts value. Every time I run select from SP_cache objects, that use counts in that first row is increasing. Now, what is this big one here? That's something that SQL Server is doing in order to support me running of this, and we're not going to look at that right now, but when we get a little bit deeper into the metadata, we might be able to see what this other row here is. But every time I run select star from SP_cache objects, that use counts value is increasing. It's using the same plan every time. So I also have another script which basically just shows you some of what I just pointed out to you. Clearing out cache doesn't really clear it out. But now I'm filtering this to just look at things that aren't in the master database, and there's just this one row for the plan I'm using. So this is the metadata I'm going to be using primarily, for at least for the first part of the presentation, to show you what's being cached and when those plans are being reused. We'll be selecting from SP_cache objects. We can compare it to the compatibility view sys.syscache objects, which is usually going to have quite a few more rows in it because it has all those other things that I'm ignoring. I don't have any CLR objects, but I certainly have parse trees here, which are used every time a view is resolved. So now let's take a look at how SQL Server decides what to put in cache and what gets reused. I mentioned there were 3 different types of cached objects. We have ad hoc query plans, we have parameterized queries, and we have stored procedures. And as I talk about these 3 types, I'm also going to talk about what's the deal with parameter sniffing. Is this something that you should get all worried about? And the answer, of course, is 2 words. Yes, music to my ears. It depends. So ad hoc plans are what SQL Server uses when it can't use either of the others. It's basically the default operation, the default type of plan. If it's not a stored procedure plan, if it can't be prepared or parameterized, it's treated as ad hoc. But we're going to start with that, even though it's usually like the 3rd choice, because it's the simplest to start with. However, in some cases, it's not quite so simple, because in order for an ad hoc plan to be reused, you have to submit the exact same SQL text. If the optimizer notices, oh yes, someone submitted that exact same query, I'll run with the same plan. If there's any differences at all, SQL Server will not reuse the plan and it will come up with a new one. And any differences doesn't just mean changing the parameter or changing the value you're looking for. Give me all the customers in Minnesota and then give me all the customers in Texas. Yes, maybe I would accept a different plan for those 2. But if you change your query to put a new line in after the from, or change the case, or add a space, any textual change at all to your query, SQL Server will not recognize it as the same query, and an ad hoc plan will not be reusable. We'll see this in the demo in just a minute. In addition, if you change your environment, basically that means your set options. If you change your set options, change from ANSI nulls on to ANSI nulls off, the same plans that were generated when ANSI nulls were on will not be reusable when ANSI nulls are off. And there's a whole long list of set options which have this same behavior. It's not every single one of the possible set options, but it is quite a long list. It is documented. You can take a look in the books online, but for now, just be aware. Most of the set options which have to do with how SQL Server processes your queries mean if you change them, any generated ad hoc plans will no longer be usable. Now, I mentioned the condition called cache bloat a few minutes ago, where cache gets flooded with thousands or hundreds of thousands even of ad hoc plans with a use count value of 1. This can end up eating up a lot of your memory, because the minimum size for a regular query plan is about 3 pages. Pages are 8K, 3 times 8. 24K is the minimum size of even the simplest plan. 24K times 100,000 plans. Anybody want to do the math? That's okay. The answer is big number. Lots and lots of memory can be eaten up with hundreds of thousands of ad hoc plans, and if you're never reusing them, they're basically wasted. So 2008 introduced a configuration option called Optimize for Ad Hoc Workloads. It's just a Boolean. You turn it on or you leave it off. The default is off. Once you turn it on, SQL Server is a little bit more conservative about caching ad hoc plans. The first time any SQL string is executed, SQL Server will not store the whole plan. It will only store what we call a stub. And a stub is only 300 bytes. Much less in the big multiplication scheme than 3 pages, than 24K. Multiplying 300 bytes times 100,000 is a much smaller number. It's not 0. But it's a much smaller number than if you had full-size plans. Question? If the question is, well, actually, the question is, exactly what makes the plan different, or why is Texas and Minnesota 2 different plans? If it's hard-coded, where state equals TX, where state equals MN, that is different text. If it's an ad hoc query, those will not be considered the same query. Now, we'll be looking at things other than ad hoc plans where we might be able to use the same plans for Texas and Minnesota. And we'll see that as we go through. But if SQL Server's decided this needs to just be cached as an ad hoc plan, I'll tell you why in just a minute, why it would decide that versus the alternative, then TX and MN are 2 different strings, and those are 2 different queries. So, but that's jumping the gun a little bit, but it's good to be thinking about what your further questions are. For Optimize for ad hoc workloads. Once you turn it on, it's a server-wide option, a configuration option. Once you turn it on, it stays on. Any ad hoc plan will then only first store 300 bytes as a stub, and the next time you run the exact same text, then SQL Server will say, oh, I guess this is a popular one. Oh, I guess this is one you're going to be reusing, and it will replace the 300 bytes by the full text string. But the first time you run any text, you will get only the stub, and only on a second execution will it get replaced by the full plan. That is a 2008 feature. Question here. I wondered if someone was going to ask, what is the downside of having optimized for ad hoc workloads on? And I've thought long and hard about it. The default is that it's off. You need to turn it on. And I've received this question multiple times. why not just make it the default? The reason for not making it the default as far as the product team is concerned is backward compatibility. It wasn't the default in older versions. I actually asked one of the engineers if they could think of a reason why this might be a bad thing to have on. And he had to think about it for a while. And he came up with one case, which, believe me, is a very edge case, which is if you have a whole bunch of really, really complex plans that are all only run twice. If that's your environment, this might be a bad thing. But if that's not your environment, then probably this will not hurt you. It might not help you, but it probably wouldn't hurt you. Sebastian, you had an example? Okay, the comment is Ken Henderson's 2005 book made a comment about this, which is really surprising since this is a 2008 feature. Are you sure that he wasn't talking about the forced parameterization feature? Forced parameterization is something that was introduced in 2005. It's not the same. It is not the same at all. Forced parameterization is something very different. We'll look at that very shortly. This is just saying don't even cache the plan at all. If it's the first time you've run it. Just cache something so that we'll know the next time we run it that it is the next time we run it. It's just a sort of a marker so that we can know that it's the second time. And I have not yet found a reason for not having it on, but it is not on by default. So let's look at a few more examples. The examples I just showed you in the first look at the metadata were ad hoc plans. And I'll have a few more in demo number 2. Question over here. Yes? So the question is, how is this optimized for ad hoc workloads? It's because the stubs are so much smaller. Cache will still look, when you run the metadata queries, it will still look like you've got your hundreds of thousands of plans in there. But as far as what it's using, the resources it's using, it's a lot smaller. 300 per plan versus a minimum of 3K per plan. 3 pages, 28K per plan. That's the difference. Not number of rows, but total size. Okay, so a few more quick examples here. In my AdventureWorks database, I'm going to make a copy of the table called sales order header, just because I don't want to mess around with the real table. So my table is called new sales, and I need to update it to, I want an integer. Oh no, what I'm doing here is I'm chopping off the cents values, converting it to integer, and then back to money. And building a unique index now on sales order ID. And a non-unique index. Both of these, notice, are non-clustered indexes. One of them is unique, sales order ID. One of them is non-unique on this value called subtotal, which is, I probably don't want it to be unique because it's perfectly possible that I'm going to have lots and lots of sales with the same subtotal value. So, when is an ad hoc plan reused? Take a look in cache. All I have is the row here. And notice that in my SP cache objects, I have the row called use counts. I have the row called, a column called use counts, a column called pages used. There's my 3-page minimum. And all the way off on the right, I can see the actual SQL text. And here it is, select from SP cache objects. So here's an ad hoc query. Select where subtotal equals 4. It gets cached as an ad hoc plan. There it is. One use. If I run the exact same query again, the use counts goes up, but if I change the parameter value, there's a new row. If I add the comment, there's another row. If I add a new line, there's a new row. Anything I do to this query makes the old plans not reusable because these are ad hoc. Why are they not something better than ad hoc? Well, we'll see that in just a minute, what you have to do to get something to be a different kind of a plan. So let's take a look at the Optimize for Ad Hoc Workloads option. This is a SP configure option. And once I do this, and go back up to the top and clear out cache. All right, where am I? I'm looking for my DBCC free proc cache. Oh, there it is. Clear out cache and start again, and this time we'll run this query. And what we have for it is a stub. Actually, both my queries, my select from my sales table and my select from SP cache objects are both stubs. Because it's the first time I've run either of them, pages used gets rounded down to 0. 300 bytes is just a tiny fraction of a page. It's not using up much memory. But the second time I run the same exact query, and this query also happens to be the same exact query as before, both of the stubs got converted to full plans. Both of them use the minimum of 3 pages here. Question? You know, that's a very good question. When you run SP configure, does that clear out cache? In older versions, most SP configure changes would actually clear out cache. As of 2008 and 2008 R2, it's a lot fewer of them. And I apologize, I meant to show you that cache was not cleared out when I changed this one in the R2 version that I'm running here. But in 2005 and earlier versions, many of the SP configure changes would actually clear cache, all of cache, which then would surprise people when everything had to be recompiled unexpectedly. So here's another query which looks very much like the ones we were just running. Just to remind you, the query I was just running up here that showed up as an ad hoc query was either select from sales where subtotal equals 4 or select where subtotal equals 5. Now this looks like a very similar query. Select where sales order ID equals some particular value. But that actually turns out to be the second type of cache object called a prepared plan. What is the difference? Why is this one treated differently than this one up here? They both have indexes. Subtotal and sales order ID both have indexes on them. One of them, however, is a unique index. Okay, so that's the difference, but why should that matter? Why should it matter that it's a unique index? Well, this relates to an issue that you might have heard about or seen in another presentation at the conference this week, having to do with when non-clustered indexes are useful or not. And here is the 10-cent simplification of when non-clustered indexes are useful. Non-clustered indexes are useful when you're looking for a few rows. They are not useful when you're looking for lots of rows. Now, I'm sure most of you could come up with exceptions to that, but we're going to take that as our oversimplification because this isn't a query tuning session. Non-clustered indexes are useful when you're looking for a few rows. They are not useful when you're looking for lots of rows. When I say select from new sales where subtotal equals 4, how many rows do you think I'm going to get back if I change this to some other value? 4 returned 95 rows, but 5 returns 576 rows. Some other value might return 0 rows. Some other value might return 20,000 rows. Different values will return different numbers of rows. So what index should I use? Is it a few rows or is it a lot of rows? It depends. It's treated as an ad hoc query because the plan for one parameter is not necessarily going to be the right plan for a different value. Some of the values are going to be able to use the non-clustered index, others won't be. Whereas, when we look down at this query, how many rows are going to be returned? 1 or 0. Those are the only possibilities here. Both 1 and 0 are considered a few rows. So for either 1 or 0, a non-clustered index can be usable here. So it doesn't matter. I could change 55555 to 66666 or 73982 or 31459, any value I want, and at most we're going to get 1 row back. That is what makes this query different. That is what makes this query what we call, or the plan for this query, a prepared plan. And in fact, what happens with a prepared plan is that SQL Server automatically parameterizes the plan. We have a question over here. I didn't catch the second part of that. I'm sorry, I still can't hear that. Oh, you can always hint and tell SQL. The question is, if you use a hint, oh, what kind of plan will it be? You know, that's a good question. It would be real easy to test out, and we may do that, but I can't remember whether when we use a hint. No. If you tell it to use a hint, to use an index, and there is that index, it will use that index. The question is, will it show up as a prepared plan or an ad hoc plan? That I would just have to run and see. But the issue of prepared versus ad hoc is the plan reusable? And that's what we're going to be looking at now. When we look at this code, you'll see that you can actually easily test out and find the answer to that question yourself. So, a parameterized query. Let me just jump back quickly to the demo I just showed you, because I meant to do one other thing for this row for the prepared plan, and that is scroll off to the right here and show you that it has been parameterized. The plan doesn't actually mention the actual value here. The plan is parameterized for whatever value comes in. Now, let's talk a little bit more about what happens when we have a parameterized plan, and then we'll see some more examples. When SQL Server parameterizes, by default, it really only parameterizes a very few queries, a very small class of queries, because it wants to be sure that parameterizing is a good thing. It wants to be sure that the plan it comes up with really is going to be a good plan as you run slightly different queries. If you don't think that SQL Server is being serious enough, if you don't think it's being aggressive enough at parameterization, there is a database option. This was introduced in 2005 called forced parameterization. You turn it on for a particular database, and it makes SQL Server much more likely to parameterize your queries. Now, this is something that does take a lot of thought and really, really depends on the kinds of queries you're running. I have seen some situations where forced parameterization made a world of positive difference, but I've also seen cases where forced parameterization makes a world of negative difference, hurts performance. So we'll see some details about and some examples of when it's a good thing and when it's not. Simple parameterization, there are only a few queries, like the one I just ran, which will be automatically parameterized. Forced parameterization says, yeah, just go parameterize everything, or almost everything. There is also an option to explicitly parameterize. Auto-parameterization is when SQL Server does it on its own. Explicit parameterization is when you say, here's my query, this is the value to treat as a parameter. And that's very difficult to do from a query window in Management Studio. Normally, we explicitly parameterize through our application by saying prepare and execute. Prepare this query is how we would explicitly specify parameters. Now, through a query window, we can simulate that by using a stored procedure called SP execute SQL. So I will show you a couple of examples of that. So, question over here. If SQL Server has parameterized the query, it will use the same plan no matter what specific value we pass in. Looking for 55555, looking for 10, looking for 839. If it's been determined to be a prepared plan and SQL Server parameterized it, it means, yes, it will use the same. It will treat your values as a parameter and use the same plan every time. Is that a good thing or a bad thing? Well, that's what we're here to find out about. So, auto-parameterization. Let's hold some of the questions. And actually, I would bet that some of these are going to be answered in the demo. So at least hold on to the demo for follow-up questions here. So when SQL Server decides to parameterize, it decides not only what values in your query it will treat as parameters, it will also decide what data type the parameter should be. It will look at the value and says, this looks like an int, or this looks like a character string. This looks like a tiny int. It will come up on its own with a data type, and different queries that have different assumed data types may not use the same plan. Also, if you change set options, even with a prepared parameterized plan, you may not get the same plan to be reused. In addition, when SQL Server parameterizes a plan, it will come up with what's called a shell query for every execution of a prepared plan. Every time you execute the same prepared plan, it will store something called a shell query. I'll show you that in the demo, which is not the full plan, but it's not as small as a stub either. It's always at least 16K, substantially bigger than a stub, but not the full plan. And this is what SQL Server uses to find the corresponding parameterized plan. That will be a little bit clearer when we actually look at the metadata. Now, in order for SQL Server to say, yes, I'm going to parameterize this, you need to meet some requirements. The plan must be safe. I consider that the #1 requirement, which means there really is only one possible plan. Going back to my index example, with a unique index, there is only one possible plan. Whether I say 47, whether I say 932, it's only going to be 1 or 0 rows, so let's use the same plan. It's considered safe. Whereas when I select looking for a value that isn't unique, there might be a few, there might be a lot. There can be different plans for different specific values. That is not considered safe. There are multiple possible plans. A plan that isn't considered safe will not be automatically parameterized under simple parameterization. In addition, if the plan is not simple, simple parameterization requires simple queries. And a non-simple query is one that contains anything in this list here. And you might start looking at the list and say, okay, I can get away without using in clauses or bulk insert or update with a set to a variable. Yeah, I can see why those might be complex and non-simple. But if you scroll down the list, down, the fourth one from the bottom, the fifth one from the bottom, anything with a join is not considered simple for the purposes of simple parameterization. Any query, no matter how simple you think it is, will not be parameterized if there is a join in it. So this is one of the main reasons that people don't like simple parameterization and say, let's do something different. We have these queries that look almost the same, but they have a join in them. They can't be parameterized by default, so we can change our database to act under forced parameterization. Database option, alter database, set parameterization forced. And once you set parameterization forced, SQL Server is going to start parameterizing almost everything. Parameterize the heck out of your queries. There are still a few exceptions. Of course, there's always exceptions. It's a much shorter list here. I'm not going to step through it, but almost all your queries will be parameterized once you change your database to forced parameterization. So let's see what that looks like. So demo number 3, auto-parameterization, again, is when SQL Server chooses to parameterize on its own. I can look in sys.databases, and it tells me that for my AdventureWorks database, is parameterization forced is not on, which means it's simple parameterization. So I'm going to clear out cache, make sure I'm in AdventureWorks. The only thing that's in there, did I not turn off? It looks like I didn't turn off my optimize for ad hoc workloads. Oh, the proc was the SP configure proc. Clear app cache again. Nothing there but the query I'm running. And now, again, we're selecting from looking for a value in a column which has a unique index, so this is parameterized. Scrolling to the right, we see the parameterized query here. The parameterized query doesn't have the actual parameter. We also see this row here. This is the shell query. There is nothing in this row here that really makes it clear this isn't the full plan. When we look at the metadata, I will show you how you can verify that this is not really the whole plan. The size of it is a little bit smaller. Oh, you know what? Oh, there we go. No, the size actually is 3 pages. So it's certainly not as small as a stub, and every time I run this query with a slightly different value, I will get a different shell query, but the parameterized form is being reused. Parameters for the prepared plan was reused. I have a second shell for each separate execution value. So lots of different values, and here I can be a lot more generous with how I change my queries. I can put in a new line, I can add a comment, and even though I get different shell queries each time, there's only one prepared plan, which is really the full query plan, and I've now used that several times. Now, let's look at forced parameterization here. I'm going to clear out cache just to keep things easy for me to manage. And the query above was both safe and simple. If I join my table called new sales with sales order detail, this actually is still a safe query. There still should be only one plan that's usable. But because it has this join in it, because it has the join, it will not be automatically parameterized. When I look in cache, it's an ad hoc plan containing the full join. So the exact same query with a different value, still just returning a few rows. It should be able to use the same plan, but I get a completely new plan in cache. This is safe but not simple, and I'm getting very frustrated because I would like the same plan to be used every time. This is a case where you might consider using forced parameterization. If most of your queries do involve joins or group bys or something from that list, but you know that they are safe, you know that they all should use the same plan no matter what specific value you're looking for, you can test using set parameterization forced and see if it helps performance. Once I've set parameterization forced, now this change actually does clear cache. A number of the altered database options do clear all the plans for that database. Now that I have parameterization forced, this query will be parameterized. It's now a prepared query, and that query uses the same plan. So I've got a prepared plan with a use counts of 2, even though it has a join in it. So this could be a good thing, the same plan being used every single time I run this query, looking for this sales order ID, looking for that sales order ID, looking for another sales order ID. If it's all the same plan, I don't want multiple plans in cache. This is a good thing, right? Question? I'm sorry, say that. Because I'm using a parameter here. I say where database ID not equal 1, and that the question was, why was this query? Oh, why was it not parameterized? It is parameterized because I'm under forced parameterization. Yes, and I am in the database. It's the database I'm in running the query. I am in AdventureWorks, so every query I run in AdventureWorks will be parameterized. Not where the object is, correct. What my context is. Question back here. Cursors, the selects within cursors also will prevent parameterization even under forced. Yes. Now, so this is a query that might be a good thing. It's not parameterized under simple. It is parameterized under forced. So this might be a reason to explore forced parameterization. But be careful, because with forced parameterization, even unsafe plans are parameterized. And that can be really bad news. Let's look at this query. Well, I've got a unique index on sales order ID. What's the problem here? It is not an equality. With an inequality, how many rows are going to be returned? Sometimes a few, sometimes a lot. I could return every single row in the table here. In this case, I'm only returning 41 rows. And I cached the plan. It's a parameterized plan. Select from new sales, where sales order ID is sales order ID less than some parameter. So now, anytime I run this same query with a different value, I should use the same plan. And is that a good thing or a bad thing? Well, let me show you an example here. Looking at the example I just ran, took 43 reads. Not a big deal. Change this to another value, and 31,000 rows are returned, and it took 31,000 logical reads. How many reads would it have been to do a table scan? Well, we can find that out just by select without a where clause. There are 31,000 rows in the table. A table scan is only 799 reads. Did anyone ever hear that table scans were the worst thing that could happen? Not. There are things that are much worse than table scans. And here's one example. One example is to use a plan that was designed for one parameter and use that same plan with a completely different parameter. 799 reads. If we do a table scan, I'm getting 31,000 reads because it's using a plan that was developed for a different parameter. This is a case where automatically parameterizing is not a good thing. So you need to test your applications, your queries. If you want to explore using forced parameterization, make sure it helps things and doesn't hurt them. Question over here. So the question is, can you override this forced parameterization? The only real way to override forced parameterization is to use a plan guide. And in the plan guide, you could say, the hint to add to the plan guide would be optimization simple or parameterization simple. And that you can do it that way. And vice versa. If the database is set to simple, you can have a plan guide to say, for these queries, do it forced. If the database is set to forced, you can have a plan guide that says, for these queries, do it simple. There is a hint that says parameterization simple and parameterization forced, but that hint is only usable in plan guides. Now, in the general case, though, what I could do here is just add the option recompile hint and say don't use an existing plan. It's not the same as forced parameterization or simple. It's saying for this query, come up with a new plan. And now if I say come up with a new plan, it doesn't use the plan that was already cached. It comes up with a fresh new plan just for this one particular execution. Now, one quick thing I just want to point out to you is problems with data types. I'm going to set my parameterization back to simple, which pretty much cleared out cache, but I'll make sure it's cleared out. And look at this query here. This isn't back to an equality. So this parameterization should happen automatically. This is a safe query now. Parameterization did happen. And look at the data type of the parameter. SQL Server decided, oh, look, 55, that looks tiny. We'll make that a tiny int. How big can a tiny int be, however? Tiny. Can't be very big at all. 555 won't fit. 555, well, no rows are returned. But I have a second plan, one for a small int. I will not reuse the same plan. How big can a small int be? Anybody know the max small int? 32,000 and change. So 55,000 is too big. So we get a third prepared plan for this one. One for int, one for small int, one for tiny int. Plans will not be reused if SQL Server determines it's a different data type. Well, what if we what if we start with the int, clear out cache, and start with the big number? And then go to the medium-sized number, and then go to the small, tiny number. How many plans do you think we're going to have? We still have all three. The optimizer actually decides what data type it is before it goes to look to see, do we have a plan for this already? It decides, oh, this looks like a tiny int. Nope, no tiny int plan in here, so it makes one. It doesn't look and say, oh, could it fit into this int plan? No, it doesn't do that. So you might need to be a little careful about your data types. Casting might help. Variables have their own problems, which are beyond our scope today. But at this point, I just want you to be aware that there can be problems with plan reuse if SQL Server doesn't know up front what the data type is. So a solution to a couple of problems here is for you to be explicit and say parameterize this. Through your applications, you would say prepare, and you would pass in the query and the parameters and the data type. From a query window, we can use a stored procedure called SP-execute SQL, to which we pass in a query, the parameters, and their data types. If we explicitly prepare a query, we tell SQL Server up front, I want you to parameterize this. Forget about forced, forget about simple, it doesn't matter. I want this to be parameterized. SQL Server doesn't bother creating a shell query. So you do save a little cache space if you use this option. There was a question back here. All right, either figured it out or changed their mind. So just a real quick look here. Now, this solves the problem of data types. It solves the problem of whether to use forced parameterization or not, but using explicit parameterization still doesn't solve all our problems. If someone uses this prepare and execute and doesn't know what they're doing, they can still end up with problems. Notice by default, this query is not parameterized. SQL Server will use an index for the small value, 43 reads. It will do a table scan for the big value, and it's only 799 reads. But if I tell SQL Server to create a parameterized plan for select from new sales, where sales order ID less than some parameter, the parameter is type int, and here's the value to look for, I'll get my 41 rows back, and it only took 43 reads. If I look in cache, there is no shell query. Here's my parameterized plan. There is no shell query for that value. Am I lying? Oh, yeah, I ran it first as 2 ad hoc queries. I didn't clear out cache again. I do not get a shell query for subsequent executions. I should have cleared it out again. Run the query. No shell query. Only the SP cache objects has an ad hoc plan. So now I have a plan, and I can reuse it. But again, it's up to me as the code writer to know whether this is a good thing or not. To pass in a completely different parameter, we're telling SQL Server, use whatever plan you already have, but this time use a different value. This time, it's using the existing plan to look for all the values less than 77777, and it turned out not to be a good thing. It turned out to be worse than a table scan because it's using a plan that already exists. So explicitly preparing your queries doesn't give you any guarantee that you're only going to parameterize when appropriate. You still need to know whether this is safe to do. Now, what is this called when we are using the same plan even though we're changing the parameters? This is parameter sniffing. A lot of people think parameter sniffing just applies to stored procedures, and it certainly does apply there, but it also can be an issue with parameterized queries. And the next question is parameter sniffing a good thing or a bad thing? The answer is, Well, I don't even want to say it depends. I'm going to say it's a good thing when it's a good thing, and it's a bad thing when it's a bad thing. And one thing that I've noticed is that people always tend to use parameter sniffing. In all the blog posts and all the articles that people talk about parameter sniffing, they always cast it in a negative light. Solve your problems with parameter sniffing, removing parameter sniffing, or dealing with parameter sniffing as if it's always a problem. If they always use negative adjectives with it, people start thinking that parameter sniffing is a bad thing. I just saw an article the other day called Solving the Problem of Parameter Sniffing. No, in itself, it's not a problem. And I thought of an analogy. It's like digestion. If all you hear about is people talking about problems with digestion, you might start to think that digestion was a bad thing. Is it? No. Digestion is a problem when there's problems with it, but there's not a problem with digestion when there's no problems with it. If there are problems, you need to solve it, but in itself, it's just a thing, and when it works well, it's a really good thing. The parameter sniffing is the same thing. It can be a good thing to reuse plans, but when there are problems with it, when the plans are used inappropriately, then is when we need to do something about it. And it's a little easier to do something about it if we have our queries written as stored procedures. Not only do we have control over what's a parameter and what the data types are, but with a stored procedure, we have a little more control over when a new plan is developed. We can say, execute this procedure with recompile. We can create the procedure with recompile, so we will get a new, fresh plan every single time. Now, I know a lot of people, when they first see this option, get a little concerned. For years and years and years, one of the main marketing messages about stored procedures was how wonderful they were because they reuse their plans. Well, reusing plans is a good thing when it's a good thing. But just because you're not reusing the plan, does that mean stored procedures are not a good thing? There are a lot of other benefits of stored procedures, like modularization of your code, like reuse, like less traffic over the network. Lots of good things about stored procedures, but being aware that you might not always want to reuse the same plan can be a good thing. So here's my slide about parameter sniffing. I jumped the gun a little bit there. It's not necessarily a bad thing. It's just what SQL Server does. Oh, and actually I came up with this digestion analogy when someone posted a question, I think it was to SQL Help on Twitter, is there a way to tell in plan cache if parameter sniffing is happening? That would be like saying, is there a way to tell if optimization is happening? Where is that shown in my plan cache? No, it's just what SQL Server does. It will do parameter sniffing if you have one of the types of plans that supports parameter sniffing. And by looking at the type of plan, that's how you know whether parameter sniffing is happening or not. Is it a prepared plan? Is it a procedure? Then you've got parameter sniffing. Ben? If you have create procedure with recompile, that does not demote it to an ad hoc plan. So your optimized for ad hoc workloads is irrelevant. The hint option recompile is something a little different. But actually, in either case, when you say recompile, SQL Server doesn't cache the plan at all. Stub or ad hoc or proc or anything. When you say create with recompile or execute with recompile, it will not cache that. So you won't see anything in cache. So safe plans with simple parameterization, we can think of them as using parameter sniffing. The first parameter determines the plan, but there's not going to be any problems. Because it's a safe plan, that means there's only one possible plan, and we've got it on the first parameter, and we keep using that same one over and over again. Parameter sniffing applies when we have set our database to forced parameterization. Parameter sniffing applies to stored procedures and all our explicitly prepared plans unless we override that with the recompile option. This is not the query hint. That's a tiny bit different. Similar, but a little different. Oh, come on. Let's see. Just a couple of quick stored procedure examples just to show you that recompile option. I'm going to create a stored procedure that does the query I've just been running, and I didn't grab my whole thing. So select from new sales where sales order ID less than some parameter. So call the procedure with a small parameter. It's a small number of reads. And I have a row for a proc here. It just says, there's the proc. It will also tell me use counts so I can find my most popular procedures. And then I call the same procedure again with a different parameter that does a whole lot more reads. Here's parameter sniffing being a bad thing. So the solution here, what we do see though, is I now have a use counts of 2. I can say, oh, I don't like that performance. Let's see if recompile will make a difference. And sure enough, there's a lot fewer reads. But when I look in cache, there's no separate proc plan, and the use counts didn't go up. It was like a one-off that's just plans created and it's thrown away. When I say exec with recompile, there's no record of that plan saved in cache. But if I determine that the performance is much better when I say exec with recompile, I can then decide to recreate the procedure to recompile every time. And once I do that, plans are never saved. It removes existing plans. There are no procedures here. And every time I run this procedure, I will get the best plan for that parameter. I will get an index use for the small parameter. I will get a table scan for bigger parameters, but none of these plans will be cached. No procs here at all. So the last thing we'll look at for our last 15 minutes or so, hopefully not quite that long, so there'll be time for more questions, is the metadata available now that we can actually look more into what's in cache. So I mentioned the dmexec cached plans. There is also a view called dmexec query stats, which gives us a little more information. There's separate details on each of these features over the next few slides. dmexec requests, which a lot of people use as a replacement for SP-who or sys processes. It shows you you're currently executing operations. That gives you information about your plans and what's in plan cache. There are a couple of values that these views return. There is a value called SQL handle and a value called plan handle. I will show you what you can do with them. There, as of 2008, we also have something called query hash and query plan hash for detecting whether we have similar plans. We also have a couple of functions that can be used to translate these handles. SQL handle can be translated with exec SQL text. Plan handle can be translated with dmexec query plan or dmexec text query plan. We'll see the details. So the three views that we're going to look at, dmexec cache plan, I think of this as the main view with one row for everything that's in cache. But remember, it's one row per batch. So if there are lots and lots of statements in the batch, you don't see the statements individually. All the statements show up as one row because they're one batch. You do have a column called plan handle, which allows you to see the plan for that batch. I'll show you how to do that in just a minute. Exec query stats actually takes your batches with multiple statements and breaks them apart. It does return one row per statement. But because what's cached is the entire batch, it has to tell you where within the batch each query starts and stops. So it has a value called the statement start offset and the statement end offset, so you can actually pull out the specific query text from within the larger batch. It has both a plan handle and a SQL handle, and I will explain these values really soon. And then exec requests has one row for every currently executing batch. If a batch is currently executing, you get a row in DM exec requests. You don't get any rows for the queries that were run a few minutes ago that have been completed. Even if the connection is still live, if the query is not running, you will not see a row in exec requests. So we have these two very useful values for starting to pull things out of cache. We have SQL handle and we have plan handle. SQL handle translates into the text of the SQL statement. Plan handle allows us to actually pull out the query plan. And if you think about the cardinality, the relationship between SQL handle and plan handle, sometimes it can surprise you. SQL handle and plan handle are in a one-to-many relationship, but it may not go the direction you think it goes. One SQL query can actually generate multiple plans. The SQL query is not guaranteed to always give us the same plan. So one SQL handle can have multiple plan handles for the same exact SQL text, but one plan, has anyone ever looked at the XML plans? XML plans include the SQL string in there. Every plan maps to exactly one SQL statement. One SQL statement could actually generate multiple plans, but one plan always has one statement that generated that plan. And then the hashes, we may not have time to talk about that. I do have a little example in the demo I'm about to show you, but if we have time, I will mention that as part of the demo. The functions we'll be looking at are the translation functions. Exec SQL text is a table-valued function to translate either a SQL handle or a plan handle to a query. Exec query plan translates a plan handle to a plan. Once we have actual plans, we can start poking around in them, querying the metadata using xquery. And I will show you a real quick example of that on the slide. I'm not going to explain it here. We'll see it in the last demo. So exploring our cache info here, in my AdventureWorks database, clear out cache, and run one batch that has two queries in it. Similar, but not exactly the same. Now when I look at exec query stats, and I look at exec cache plans, exec query stats has one row for each statement, and the only thing I want to point out here is the start and end offset. One of the statements starts at 0 and goes to 110. The next statement starts 2 characters later because there was a space in between, and -1 means it goes to the end of the query. So there's the first statement, there's the second statement, each itemized separately. The plan is the same. There's only one plan for the batch. We can't get the plans for the individual statements. But this also gives us information about resources used, how much time, how many reads, how many writes for each of the statements in the batch. For exec query plan, exec cached plans, I only have one row for the entire batch. And which one is it, though? Which row here is the one for my batch? Well, I can't tell just by looking at this. This is what I meant at the beginning of the presentation, saying this information was pretty darn cryptic. I can take this value, however, and translate it using my function called exec SQL text. Plug in that handle, and it shows me, well, that's not the one I wanted. That's dm exec query stats. That's not the statement that I'm interested in. So I might have to go back and look again. Now I've got a whole bunch more and try to grab one of these out of here. And it could take me a while to take every single statement out of there and translate it into a SQL query and say, is this the one? Is this the one? Is this the one? I've only got 9. Some of you might have more. You might have 10 or 10,000 or 10 million rows in cache. Not real efficient to go row at a time. So what we can do is we can actually combine these functions with my exec cache plans to make it look almost like a join. To join exec cached plans with this table valued function, passing in plan handle as a parameter to exec SQL text and passing it as a parameter to exec query plan. I think of this as joining a table to a table valued function. But don't let Itzik Ben Ghan hear you say that or hear me say that. I said this once in front of him, and he gasped and said, no, this is not a join. And he gave a big, long explanation of exactly why it wasn't a join, but like I use it like a join, and that's the way I remember what to do is by thinking of it like a join, but it's really not a join. But once I not join these together, I have a row for everything in cache with the text and the plan. So if I want to find the plan for some query, I might be able to find it. I could add a where clause to search this text column for something interesting to me, and then find the associated plan over here, click on the XML plan, and there it is. Now, I'm not in a position to explain all the details of the XML plan. That's another session given by somebody else this week, but pulling up the plan is a good first start to seeing what SQL Server was doing with that query. I've got the plans, I've got the text. I can search through the text to find queries that are selecting from some particular table, but how could I search through the plans to look for plans that are doing bad things, like hash joins or table scans? We have a tool called xquery. It's actually a language. And I am reproducing a query that my friend Bob Boscheman blogged about actually several years ago, but it's a wonderful little query. He created a stored procedure called look for physical ops, which uses xquery to search the results of this join here. I am not an xquery programmer. I am not an XML expert. I can barely spell XML, but I love this query that Bob wrote, and I've actually been able to modify it and do a few other different things. But first of all, you have to know what is a physical op. A physical op is what comes back when you set show plan all on and you look in the column called physical op. Anything that shows up in this physical op column is something that we could search for. We could search for nested loops. We could search for clustered index seek. We could search for table scan, might be another value. Anything that we ever see in this column is something that we could search for. This set options are always only for the connection. Always. So I'm going to just run a few queries here to put some interesting things into cache, doing some table scans, and oops, I didn't mean to do that. I meant to turn off show plan all. Let's clear out cache and run some queries that are going to do some scans and some hash joins. Takes a few minutes to do those things. But after my users start complaining, why is this taking so long? We're almost out of time here. Let's get on with it. Why did this take so long? I can start poking around in cache, and one of the things I might want to ask, well, was anybody doing table scans? And it will show me the queries that did table scans. was anybody doing hash joins? And it will show me the queries doing hash joins. Was anybody doing a clustered index scan, which is the same as a table scan? And I can find the queries that might be misbehaving. Be careful. This is not something I would do every few minutes. Certainly not every few seconds, and just keep polling and grabbing all these values. On a large cache, this get physical ops can be expensive. But what you could do is run this query and save it off into another table, which you then can start analyzing. Here, this wasn't that, it's not expensive to run this because my cache is so small. I do not recommend it at all on a regular basis, but when you do have a slowdown and you suspect there are some bad plans and slow running queries, to be able to start looking at the plans in cache can be a really helpful thing to do. So, what I wanted to give you this afternoon was a basic idea of how SQL Server decides what to cache and how you can see what's been cached and how it's been cached as an ad hoc plan, a prepared query, which means parameterized, or as a procedure. And then I wanted to introduce you to the metadata, which will allow you to go in and start pulling things out of cache for your own explorations. I will be available for questions. Please fill out the evaluations. I appreciate it. PASS appreciates it. Your colleagues here will all appreciate it as well. So thanks very much for being here, and have a good evening. Thank you. Questions, and I think I'll keep the mic on for other people to hear, and you want yours back.